Good afternoon. This is Dr. R. Karthik, and today we are going to discuss about the basic elements in a control system. So, what are the contents we are going to discuss in this video? So, we are going to discuss what is a basic control system is, what are the basic elements which form a control system, and a few practical applications. Now, what is a control system? Now, a system whose output can be managed, controlled, or regulated by varying its input is called as a control system. That is, it is a system where any of its variable has to be controlled, then it is called as a control system. A few examples now, like a traffic light control system, a washing machine, an air conditioning system, a water level controller, all are a few practical applications of a control system. Even the human body itself is a great example of a biological control system. Now, a system will have an input, it will have an output, and between that, now we have a system which will regulate the output based on the input. Now, the control system can basically be classified based on the type of a signal, the number of inputs, and the feedback. Now, based on the type of signal, it can further be classified into a continuous system and a discrete system. Based on the number of inputs, it can be classified into a single input, single output system. In short, it's called as the SISO system, and multi-input, multi-output system, that is MIMO system. And based on the feedback, it is called as the open loop control system and the closed loop control system. So in today's video, we will be very much interested to see the control system based on its feedback, that is the open loop control system and the closed loop control system. Now, what is an open loop control system? Now, any system or any parameter which does not automatically correct for the variation in output, now you call that system as an open loop system. In other words, the system, the output remains constant for a constant input signal. Now, if the output, if it is changed, or if you want to change to any desired value, then the input signal has to be changed accordingly. And for any external disturbance in the system, the output may vary, which in many times is not acceptable. Therefore, the open loop system is satisfactory only when such fluctuations can be tolerated. That is, the external fluctuations is tolerated, and it is limited to certain parameter variations. Then this kind of open loop system is acceptable. It basically consists of an input and an output and a controller which will control the actuating signal to the plant. Now, this is a simple system where it does not have much complications in it. Now, we'll see few examples in the later part. Now, the next type of system, you call it as the closed loop system. Now, it is very important to note, now the previous block diagram and this block diagram, the basic difference between an open loop system and a closed loop system is formed using the feedback elements. So the feedback element is the fundamental component which differentiate an open loop system and a closed loop system. Now here, we can just consider an example of a traffic light control system. Now, if the traffic light, the red and the green signal, if it is switched on and off based on a timer, now that system, we call it as an open loop system. But if the same traffic light system, the red and green light, when it is changing based on the density or the volume of traffic on each side of the road, now that system you call it as the closed loop system, because the timer is on based on the volume of the traffic. So basically, a closed loop system, it consists of the feedback elements. Now the error detector, it compares this signal which is received from the feedback element, which is basically a function of the output, with the input signal, now to create an error signal. So this error signal, now you can see it is a function of the output. It is given to a controller which actuates a control signal to control the but there is the plant output, there is a variation in the plant output. So now the error detector, the controller, the plant and the feedback elements put together, they form or they constitute the basic elements of any closed loop control system. So now I think we have understood what is the basic difference between an open loop and closed loop system. Now here, this output, even if it changes due to any external disturbances, now it can automatically get corrected by the controller because it is again compared with the input. So the output and the input, that is the output, will almost follow the input in case of a closed loop control system. So now, as we have discussed, now the basic difference between an open loop and a closed loop system. Now in open loop system, the control action is independent of the desired output. It is totally independent of the desired output. Whereas in closed loop system, the control action is dependent of the desired output. So based on the output variations, the control action takes place. Now the feedback path is not present in an open loop system, whereas there is a feedback path present in the closed loop system. Now because there is the absence of the feedback path, now the open loop system is very easy to design, whereas here the system is a bit complicated and hence it is very difficult to design. Open loop system is a very simple system, therefore it is very economical, whereas here the system is a bit costlier. And here the open loop system, since the control action is independent of the desired output, most of the times the system is an inaccurate system, whereas here the closed loop system, the system is perfectly accurate. Now we'll see some practical examples. Now to begin with open loop system. Now I've given the example of a cloth dryer control system. Now here the actual output is nothing but the dryness of the cloths. Now what normally we do is we set a timer and then we put the cloths into the system, the dryer. Now the heating elements will start heating the clothes. So here the heat is produced which heats the cloths. Now the system does not bother whether the clothes are dried up or not. Now this system will run until the timer is it's completed. So therefore the control action is independent of the output. So such a system we call it as the open loop system. Similarly, air conditioning system, we will take an example for the closed loop system. Now where the actual output temperature is what we are much bothered about. So the temperature is again sensed using a temperature sensor, which is given to a signal conditioner unit through which the feedback controls, that is feedback signal is being produced. So this feedback signal is compared with the input temperature, and if there is any deviation in the output, now the control unit will take a correction action so that the output temperature is maintained to the desired input temperature. That is the required temperature what we set. So this it is a classic example of the closed loop system. So the advantages, or what is the basic requirement of a good control system? Now the first foremost thing is the sensitivity. So the system, it should have much sense, that is the output should get or follow the input automatically. That's the basic requirement. And then the accuracy. So how accurate our system is. Then the stability of the system. So the presence of the feedback element, there is always a chance the system may go for unstable state. So therefore maintaining the stability is another important requirement of a control system. And then next, the noise present in the system. So you should have very much less noise, the bandwidth, oscillation, and the speed. So these are few basic requirements of any good control system. So today we have discussed what is the basic elements of the control system and what are the different types of control system. So we will just discuss the next topic in the next video. Thank you very much.